Hello, everyone. Hello.
Yes, ma'am.
Hello. Yeah. So today we are going to have a open session for week 4. So let's wait for 2-3 minutes more and we will start our session. Fine.
Yes, ma'am.
Okay.
Yes, ma'am, fine. Yeah.
Dipanshu, you having any doubt?
Yes, ma'am. I have a doubt in week 3, graded assignment.
You have a doubt. What is your doubt?
Ma'am, question number 3 in graded assignment of week 3.
Yeah. What is your doubt?
I have sent you in text message. You can see there.
Yeah. What is your doubt?
Ma'am, in this question, the range of correct answer is 64.1 to 64.7, but my answer is coming like 67.7 something. I have
But
tried many different methods, but my answer is coming same 67 point something.
no,
So
the
I
range
just
is 117.64 to 118.14.
no, ma'am. The question has different values for different students. So in my portal, I have this question I have sent to you with these values. So the correct answer for these values is 64.1 to 64.7.
Okay. And you are not getting it?
Yes. Maybe there is an issue in question or the method told to us.
Yeah, at last, like after the session, I'll solve it and tell you, right? But
In last,
everybody must be having the same question, I think.
no, ma'am, everybody has different question.
Okay.
Ma'am, graded assignment third question is telling.
Third question is,
Means, is he talking about graded assignment third question?
yeah,
Ma'am,
Of
my also answer
week
is not.
3.
Yes, ma'am, week 3. The range is 63 to 4 and my answer is coming 65, ma'am.
okay, everybody's having the same answer, I think. Okay, fine.
Actually, week 3 graded assignment first question after the first question number 2 and 3 are confusing, and the formula and the derivation of the question is not
The
explained
second
in the live
question
session.
is the second question is easy, but the third one is little bit tricky. Not tricky,
But,
but
but you have to do the second question at first because you have to use the data of the second question to do the third question.
yes, yes, yes. So, ma'am, if you can please solve that doubt for us, I will be very grateful to you.
Okay, fine.
Ma'am, I have one simple question about the qualifier exam.
Yeah, what is the question?
Ma'am, first week I missed to complete the graded assignment on time, but I did second week and third week. So then I will be eligible to give the qualifier on 1st of December, right?
It's on 27th, right?
No,
December.
ma'am. For him, it will be in December 1
Okay.
because he missed the first week.
First or second. Okay, okay.
Mm.
Yeah. So ma'am, like, so I have to study till week 4. So week 5 and all further,
No, you can take classes.
okay, further I have to continue week
Yeah,
5, week 6 also.
yeah.
All okay. Okay, ma'am. Thank you.
Okay.
Your average of all the weeks should be greater than 40%. I have also missed the first week assignment of statistics 1, but I gave qualifier on the 7th of July.
Okay, understood.
Okay, fine. So, Dipanshu, your doubt, I will clear it out after the session, okay? It has been time, so we have to start the session. Fine?
Ma'am, I have asked this doubt in many session before this session. So
Okay.
they said me to ask this doubt on Sunday. So I have waited for like 3 to 4 days for
Yeah,
this
it's
one
fine. Yeah,
doubt.
I'm telling you,
And
after
now
this
you are
session,
saying that
no,
you will solve this
listen,
doubt
listen.
after this class.
Yeah, after this class, in the sense, after the session, I'm going to solve it because I have to solve this. And I have to complete the week 4 session also, and it's a very big session. So after like many of them are waiting for this session, right? Everybody is not having the same doubt. Fine. So after completing my week 4, today only I'm going to solve this. Sorry, this question. Don't worry. Fine.
Okay.
Yeah. Okay. So, Prerit, what is your doubt?
I have also doubt in week 4 tutorial 2 the question the sir is solving.
Okay, that doubt will be taken on Tuesday.
Okay.
Okay. Yeah. Okay. So fine. Can we start the session now?
Yes, sir.
Okay, fine. Okay. So today we are going to have a session for week 4. In week 4, we are going to study about the association. Okay. So we have two types of variables, right? What are the two types of variables?
Categorical and numerical.
Yeah, categorical and numerical. So first of all, we are going to like study about the association about the categorical variable. Okay. So the first step for the association, we make two-way contingency table. Fine. So for example, if I having like a situation in which I have to find out whether the gender and the ownership of a smartphone is associated. Okay. So before that, what do you mean by association?
So some kind of
The connection between two.
Yeah, the connection. What is the connection between the two variables? Like if I can summarize anything, any variable, any one variable with the help of the other variable. So what is the association between these two variables? Okay. So my two variables are like I have to find out the association between the gender and the ownership of a smartphone. Okay. So the two variables are gender and ownership. Fine. Okay. So the details that I have been given is that first detail is that there are 44 females. Okay. In gender, there are two, that is female and male. Okay. So in that females are 44 and 56 are male. Fine. And the second thing that is given is that 76 students, they own a smartphone. Okay. And 24, they don't. Fine. Then the third, it is given that 34 female students owned a smartphone. That is female and they own a smartphone. Fine. And 42 are male and they own a smartphone. Fine. These are the things that it is given. Now we will make a contingency table. Okay. What is a contingency table? It's a like two-way 2x2 table, right? So the first here let's say one variable will be here, like one categorical variable will be here, like I'm denoting here as gender, okay, and here as an ownership. Fine. So in gender, we have two categories. What are the categories? Female and male. Fine. And in ownership, we have two categories, that is if they are having or if they are not. Fine. So this is the table that we have got. Okay. So first of all, in the last column, we will be having total. Okay. This total means the number of female and number of male. And here the total means who are all owning the phone and who are not owning the phone. Fine. So first of all, how many females are there? 44, right? That is total number of them are 44. That is here we will be having 44. Then how many males are there? 56.
56.
Okay. Now next, what is 76? Who own a smartphone? That is total number of people who are owning a smartphone is 76. So in which column we will be writing it?
Ma'am, in the column total of
Yes, and
yes.
total.
Yes. Okay. And 24 of them are not having a smartphone. That is in no column. That is the third column we will be writing. Fine. Now, 34 female are
Ma'am,
owning a smartphone.
24 are there, ma'am. 26.
Huh.
You write 26.
Yeah, sorry. Okay. Now it is given 34 are females who are owning a smartphone. That means here we will be having 34, and here 42 males who are owning a smartphone. That is 42 here. And if you have to find out this one, how much it will be?
Ma'am, 10.
10, and here
14.
14.
14. So this is the way we make a contingency table, two-way contingency table. So this is the first step. Okay, for if you have to calculate the association between two categorical variables. Okay, so anyone having any doubt in this?
No, ma'am.
Fine.
No.
No,
Okay.
ma'am. Fine. It's clear.
Okay, it's fine. Okay. Now the next step is we find out the relative frequency. Okay. Uh, uh, what is the formula of relative frequency?
Frequency divided by
Individual
Jensen?
frequency by total frequency.
Frequency by
Frequency
total.
divided by
So frequency divided by total frequency. Now, so in relative frequency, we have two types of relative frequency. Okay, in a contingency table, the first is the row relative frequency, and the second is the column relative. Okay, so how do we calculate both of these relative frequency? The first one comes the row relative frequency. Okay, so here we have been given a table. This was the table that we made, right? So if I have to find out, like the first question is, what proportion of total participant own a smartphone? See, here the total is 100. So the question is, what proportion of total participant own a smartphone? So what will be the value?
76 divided by
76.
upon 100.
34 divided
96
by
upon
76.
100.
24?
76 by 100.
Yes, 76 by 100. Okay, this is the proportion of people who are owning a smartphone. Is it fine?
Yes, ma'am.
It should be 76 by
ma'am.
100, right? Yeah. So similarly, if I have to find out what proportion of female participants own a smartphone, it will be what proportion of female participants own a smartphone. So
34
how
by
many?
44.
4 by
Yeah. So how many female participants are there? 44. And out of them who are owning a smartphone, that is 34. So what will be the proportion? 34 by 44. Similarly, what proportion of female participants are not owning a smartphone? It will be 10 by 44. Similarly, we can calculate
10
for
by
me. Yeah. So similarly, we can calculate for male who are owning a smartphone and who are not owning a smartphone, right? So we would be having a table like this. The same, that is yes, no, okay, the gender female and male. So here it was like 34 by 44. Here will be 10 by 44. Here it was 42 by 56, and here it was 14 by 56, and we had a total as well, which was 76 by 100, 24 by 100. Okay. So this is the row relative frequency. Everybody got it?
Yes, ma'am.
44, 56, and 100. So this is the row relative frequency. How we calculated the row relative frequency? We divided the frequency with the total frequency. Fine?
Yes, ma'am.
Yeah. Now comes the column relative frequency. It's the same method. Column relative frequency. So it's the same only. We have yes, we have no, we have females and male. So we had how many? That is 34, 10, 42, and 10. So what was the total here? It was 76 and 20. This was the total. And what was the row total? It was 44 and 56. Fine. So how do we calculate the column relative frequency? It will be for this female, that is 34. Like we have to find out the proportion of smartphone owners who are females. So the females who are owning like the smartphone, like total number of people who are owning a smartphone is 76. So out of this, who are females, that is 34 of them. So what will be the proportion? 34 divided by 76, right? Fine. Yeah, okay. Similarly, for the female who are not owning a smartphone, it will be 10 by 24. So this is the column relative frequency. In this, each column, cell column is divided by that column total. You getting it?
Yes, ma'am.
Yes, ma'am.
Yeah. So this will be 44. So if you have to find out proportion of total participants who are female, it will be 44 divided by 100. Similarly, for males, it will be 56 by 100. So is it clear? Column relative frequency and row relative frequency?
Yes, ma'am.
Yes, ma'am.
Okay. Now, the third step
excuse
comes.
me, ma'am.
Yeah.
Ma'am, this may sound a bit basic, but actually, when they ask with reference to column frequency, and they tell us to find out like what is the proportion of the total female and male who are using smartphones to the total thing. So, what should we need to write? Is it as we obtain for that row thing, or should we use a different method?
No, what was the question? Total what?
Like if they ask for with respect to column frequency and they are asking for the total number of female who are using smartphones with respect to the total number of the sample, so what should we need to do? Is it as same as row frequency?
No, the question is different, right? See, here like 34 by 76, it is saying that the people out of the total people who are owning a smartphone. See, what is 76? 76 is representing the people who are owning a smartphone. So out of these people who all are females, this is the proportion. Fine. And if you see here, it is 44. What is 44 denoting? 44 is denoting the how many female, like what is the total number of female people there, right? So it is 44. And out of these 44 people, who are owning a smartphone. So this proportion is different and this proportion is different. You getting my point? So column relative frequency is
Yes, ma'am.
different
Yes,
and
ma'am.
row relative frequency is different. So it depends upon the question, what the question you have been asked.
So, ma'am, how can we explain that the two
Uh,
variables are associated with each other? And
yeah, I'm coming back. Yeah, I'm coming to that. I'm coming to that point. So everybody got to know how to calculate the column and row relative frequency?
Yes,
Yes,
ma'am.
ma'am.
Fine.
Yes, ma'am.
Okay. Now, then how can we study about the association between two variables? Fine. So the thing is, if the row relative frequency, hmm, if the row relative frequency is same for all the rows, okay, then we say that they are not associated. This is the first point. Okay. This is the first point. If all the row relative frequencies are not same, or we can say all the column relative frequency are not uh, are same, then we say they are not associated. And the second point is, if all the row relative frequencies are different, okay, then we say they are associated. The two variables are associated, or we can say if we have the column relative frequency different, we say they are associated. So these are the 2 points how we can conclude if there is any association between two variables. Okay, so row relative frequency are same, then we say they are not associated. If we have column relative frequency same, then we say they are not associated. Fine. And if they are different, then we say it is associated. So how do we conclude here? So see, let me take another day. Okay. So, like example one, like same example, that is gender and owning a smartphone. So first of all, we calculated the row relative frequency, right? So it was, this was, no, yes, female and male. So first of all, we calculated the row relative frequency. Like I'm calculating the percentage, okay, 22.73%, then 25.00%. We have 77.27%. We have 75%. And in total, we had 44.56. And the total number of people who are owning a smartphone was 24% and 76%. So this is the row relative frequency. Correct? Now, if you see here, okay. So if you see here, who are all owning who are not owning a smartphone is 24%, and who are all owning a smartphone is 76%. If you see the ratio of female who are owning and who are not owning is 22 point, that is 23% and 77%. Similarly, for male, we can see it is 25% and 75%. Means they are a little bit same, right? There is a pattern, right? You're getting my point. Like,
Yeah, ma'am.
yeah, so it is like 23% are there who are not owning and 77 who are owning. Similarly, 25 and 75, 24 and 76. The all the values are same actually. There is no much of difference are there, right? Bigger difference is not there. 23, 77, 25, 75, 24, 76. Like everything is same. So the row relative frequencies are same for all the rows.
uh,
You getting my point?
no, ma'am, but here is slightly different, ना?
No,
जब 25 से
see,
22.73 तो कम ही है.
no. I'm like everything is under like 23 is near to 24, right? And 25 also is also near to 24 only, right? Similarly, like what is the if we see here, 76% of the total people who are owning a smartphone. So out of this, 77 are females and 75 are males, right? So it is under this only, nearby 76 only. So the ratios are same, the percentages are relatively same. I'll give you another example. Okay. Let's see.
Like
Okay.
we should say like Similar, not same, right?
Yeah, we can say similar,
Yeah.
somewhat similar,
But
right?
ma'am,
So the proportion like 22, 77, 25, 75, 24, 76, like a little bit they are similar only. The proportions are similar for females, for male, and for the total proportion. You getting my point? Okay, I'll give you one more example. Okay, there is one more category for like if we have to compare the association between the income level and the people who are owning a smartphone. So if we are having no and yes, here we are having incomes. So someone is having high income, uh, medium, and low income. Fine. And here we have our you say the frequency with 10%, 40.9%, 64.29%, 90%, and the following will be 38%, 62%. Okay. So if you look into this table, okay, let's go by row by row. So here we see that the total are 38% who are not owning a smartphone and 62% who are owning a smartphone. Okay. And in this, see, 10% is who are having high income. They are not owning a smartphone and 90% of them are owning a smartphone, right? In low income, we see 64% who are not owning a smartphone and 35%, right? See the difference. It is 10 and 90. Here it is 64 and 35. There is a big difference here, right? The values are not similar. But in the above table, we see it was 20 to 25, right? So somewhat similar it was, like in that line only, 20 lines only, right? So in yes column, we see that it is 77 and 75. So it is, sorry, hello?
Ma'am, what if it's medium and high is almost similar, but low is slightly different? I mean, medium and high is
No,
almost
any
similar.
two. See, the thing is, all the row relative frequency should be same. All the rows, not any two, any one, or any three. All the rows should be same. It should be similar. That's it. So you got the difference between the two table?
Yes. At least
Yeah,
you need to we have to get right, ma'am. At least you need to.
No, not any two. All the rows.
I mean, all the rows you have to get
Yeah,
different,
like
not
see
similar.
all the three rows. See, in high, it is 10%, 90%, 40.9, that is 41%, 60%, 59%, 64%, and 35%. Like the values, the ratios are different, right? They're not similar. For the yes, it is different, and for the no, it is different. For high, medium, and
Right.
low, it's different. For the high, it's 10 and 90. Medium is 41 and 59. Then for low is
I'm
64
talking
and
about
35.
general, madam. If I'm talking about general, if we, high and medium has almost similar.
yeah, ma'am,
Suppose
that's my question also. If here for medium, almost almost 10, 11.9, and this one is 88 point something, then we will say that the variables are associated or not.
Which one?
If in the case of high and medium, or
Hmm.
high or low, suppose
Hmm.
for high, the percentage of no is 10%,
Hmm.
and if we suppose that low there is 11.9,
Hmm.
11.9%, and for yes 88 point something, and here is 88 and 90 are much closer than 59 and 90. So the two columns high and low are almost same.
Okay,
Two
you
rows,
you
two rows of
changed
high
the
and low.
value.
Hmm.
Yeah, okay. So,
So in that case, what
hmm.
we will define that the
But the
variable associated.
medium row is
are
not
they considered as a associated? I mean, are they considered as
So what is
see,
the condition?
no,
All the rows are different, or any anyone is different from the variables, then we can say that
No,
it's
all
not
the
associated.
rows. See, here we will consider all the rows actually.
मैम देखिए, मैं हिंदी में बोलता हूँ, अगर हाई और लो लगभग लगभग एक ही बराबर आ जाए, तो हम क्या कंसीडर करेंगे कि ये दो एसोसिएटेड है या नहीं, क्योंकि मीडियम तो इन दोनों से बहुत दूर दूर तक अलग है, दो एक जैसा है एक अलग है, तो हम इस मामले में क्या कह सकते हैं कि ये दो एसोसिएटेड और नॉट.
Yeah, that's the thing. Now, see, okay, so first of all, I'm telling you about the difference between the similar rows and different row relative frequency. Okay, so if we are in this, we are having similar row relative frequency, right? So they are not at all associated. But here we see they are different, right? So that means they are associated. That's the thing. You got my point? They are associated, means there is a difference.
तो देखिए, अगर तीन ही अलग है तो तभी एसोसिएटेड कहेंगे, या फिर तीन में से अगर दो एक जैसा हो जाए तो तब क्या कहेंगे?
No, all the threes, or all the three rows.
Okay, okay, okay. That's
Yeah.
I'm asking.
Yeah. So everybody got my point. What is similar row relative frequency and what is different row relative frequency?
I have a doubt in this.
Yeah. What is the doubt?
Ma'am, are we seeing the difference between if we consider the second example? So are we seeing the difference between the values we see column wise, or are we seeing the total value that comes out to be?
See here, just
Like if we
just
see high
see
and
from the
medium.
total, from the total, like it is 38%. See, so the high from that, like it's 10% only, right? And 64% are low. So like there is a difference. Yeah. From the 62%, we are having 90% as yes and 35.7% for low, that is yes. Yeah. So there is a difference here. But in the above example, we saw that like everything is similar. That is 24%, 76%. If you look into the table only.
So if you scroll down once, I want to ask something. Yes. So if you see the difference between high and medium, it comes out to be approx like 30%, 29, 30%, right? And for no, I'm saying.
But we are not calculating the difference here. We are just looking at that is the relative frequencies. That's it. If they are all same, that's it.
Sure, okay, I got your point. Understood now. Okay.
We are not calculating any differences or they are having differences or like nothing. We are just seeing like if they are similar or not. Right? So
okay, ma'am, got it.
Yeah, the proportion is different, right? 10 and 90, 40 and 59, 64 and 35. From these values, it's different.
Okay,
like if it was,
ma'am.
let's say, if this was 36%, this was 61%, and we had 37%, here we had 60%, and something like that. So it is a little like they're all similar, like they are in the 30 line only. You getting my point? Here we are,
39 only when we consider the row relative frequency, right?
yeah, we are considering the row, that's it.
Okay. Column wise, it would be almost similar, right?
Column, we have to calculate that. This
Okay.
is only row only.
Okay, ma'am. Okay.
Ma'am, excuse me, ma'am. Ma'am?
Yeah.
So even if they are at a negligible amount of difference, we can consider them as not associated, right? So is my inference correct?
Yeah, what? Can you repeat?
even if they are at a negligible amount of difference. Say for example, like 3.5 is the difference between both the numbers, so we can consider them as not associated, right?
We are not, that's the thing. We are not calculating any differences here. We are just seeing the values.
So they should be nearly same at least,
Yeah,
right?
they should be nearly same. That's it. The proportion should be nearly same. Like we are having 22, 77, 25, 75, right? So the proportion are same, right? With like from the total, it is 24% and 76%. So it should be near to that point only. The ratios, the relative frequency should be near that point. See, 24, 76, 25, 75, right? So in the second example, if you see, it is 38 and 62. Here we have 10 and 90, 41 and 59, 64 and 35. So it's like the frequencies are different, right? For each and every row.
Yes, ma'am. Yes, ma'am. I
Yeah,
can
that's the
understand.
thing. Yeah. So you have to just look if the frequencies are different or same. That's it. It should not be that it should be 38% only. It should be nearby 38 or it should be nearby 62%.
Now,
Okay,
what
ma'am.
if I get a similar in row relative frequency but different in column relative frequency? Is it possible, ma'am?
No. It yeah, I'll tell you that later.
Yeah, okay.
Yeah, I'm not sure about right now about it, but yeah, I'll tell you tomorrow. Fine?
Mm.
Yeah, okay. So, like this way you can tell about the association between two variables. So, what was the case? Like if you are having all the row relative frequency same, then we say that, or the column relative frequency same, we say they are not associated at all. And if you are having row relative frequency different or column relative frequency different, then we say they are associated with each other. Is my point clear with everyone?
Yes, ma'am.
Fine. Can
Yes,
we
ma'am.
proceed further?
Ma'am,
Yes, ma'am.
Yeah.
the last doubt that
Your
that
voice is
you meant about the column related frequency.
your voice is
Can you
breaking.
hear me now?
Yeah.
Can you hear me now?
Yes, I can hear.
Okay, so I'm saying the last doubt that was asked, like if we have same row relative frequency, what we can comment about the column related frequency. So it will be more or less same, right?
Yeah. Means
Okay.
either the row relative frequencies are same or column relative frequencies are same, or like row relative frequencies or column relative frequencies are different.
Okay. Okay, ma'am.
In these both of the examples, you have considered the row frequency, right?
Yeah, I'm only considering the row. You can also calculate the column relative frequencies as
Both
well.
examples, right?
Sorry, what?
Both examples, you have considered the row relative frequency.
Yeah.
Right?
Yes. You can also calculate the column relative frequencies.
Yeah.
Yeah. So, like in this example, if you calculate the column relative frequencies for both the situation, okay. So here we will get the column, like for this one, the column relative frequency will also be same. Then also it will be not associated. And if you calculate it for this example also, column relative frequency, it will be different only. In both the situation, the row and column relative frequency will be different. And in this example also, the row and column relative frequency will be same.
Hello, ma'am. Can you scroll up little bit? Ma'am,
This one?
ma'am, little bit. Ma'am, for association or not association, the both condition has to be true or only one condition is true, then we said this is associated or not
Only
associated.
one condition is enough.
Okay, ma'am.
Yeah, only one condition. Condition. Either you calculate the row relative frequency or column relative frequency.
Okay, ma'am.
Yeah, but I will tell you tomorrow if like like the question it was asked by someone, like if the row relative frequencies are same for one situation and for column relative frequencies are different. So I'll tell you about that later. Fine?
Okay, ma'am.
Yeah. Okay. Okay. Can we proceed further then?
Yes, ma'am.
Yeah. So this was numerically we calculated the association. Now we will graphically represent it. So for the graphically we represent it by the stack bar chart. Okay. So what is a stack bar chart? Okay, it is similar to bar chart only. Okay, if this is my axis, fine. So here it is like 20, 60, and here we are having females and males. Right? This is x-axis and this is y-axis. So I'm having like how many total number of females were there? There were 44 females, right? So I'm drawing a bar here, which is denoting my females. And how many males were there? There were 56. So it will be here about here. Okay. So this is a simple bar chart. Okay. So what is stack bar chart? In the bar chart only, in that column only, we divide these you can say that particular segment into two parts or into three parts or into parts in any parts. Okay, so we are having two parts, right? Who are owning a smartphone and who are not owning a smartphone, right? So there are two parts, so we will be dividing this bar into two parts, that is yes or no. So in female, how many were there who were owning a smartphone? It was nearly like 22%, right? So here, so this is the people who are owning who are not owning a smartphone. Okay, and how many males are there who are not owning a smartphone? That is 25%. So it will be nearly like this. Okay, this is the yes part about this. Okay, this is a percentage of for female who are owning a smartphone, and this is a percentage who are not owning a smartphone. Okay, similarly, this is the percentage who are not owning a smartphone in male, and this is a percentage who are not owning a smartphone in males. You got my point? So this is a stack bar chart. Like the bars are divided into segments. That's it. Got it?
Yes, ma'am.
Everyone?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Fine. Okay. So yeah. So here we see that there is like no much of association is there, right? So the thing is like 20 like you can see the width, that is this percentage and this percentage are totally like they're similar only. So we can say there is no association. So if I'm having a different bar, okay, like for the high and high, medium and low income, if I'm drawing that bar chart, we are having like this. Really that is 20, 60, 50. We are having low income, medium, and high. So how many low incomes are there? That is, there are 14 people who are having low income. Then we are having 66 as people who are having medium income, and we are having 20 as high. Fine. Okay. Now we are dividing these into two segments, right? Who are owning a smartphone and who are not owning a smartphone. So in low income level, we can see that 35% are owning a smartphone and 64%, that is, this much of them are not owning a smartphone. Fine. In medium level, we can see that 40%. So here, they are not owning a smartphone. And in high level, we see that it's 10% only. Nearby, like it's very low, right? So if you look visually in this chart, we see that it's a different, right? In this, the level is different. The level, this for medium, the level is different. And for the high, it's different, right? And in the above chart, if you look, it was somewhat similar, right? So graphically also, it is telling you that the gender and for owning a smartphone, there is no association between them. But the income and ownership is associated, right? Those who are having high income, that most of them are owning a smartphone, and who are having low income, uh, most of them are not owning a smartphone. So there is an association. You can tell about one variable, that is owning a smartphone, with the help of the income level. You getting my point?
Yes, ma'am.
Yes, ma'am.
Got it? Okay. Now comes the 100% stack bar chart. What is 100% stack bar chart? 100% stack bar chart is that in this we are considering the frequencies, right? How many low level people are there? What is the frequency of people who are having low income?
Okay.
14. Okay.
Yes, sir.
And for the medium, we are having 66,
66.
and for high, it is 20, right? So in this, we are considering the frequencies. But in 100%, we are not at all considering the frequencies. We are just considering the, you can say the count of how many of them are owning a smartphone and how many of them are not owning a smartphone. Okay, so if I draw stack bar chart here, that is, so all the frequencies, the bars will be same. The bars, this is low, medium, and high. Okay, the bars will be same, but the proportion will be different, right? So this is representing low, this is representing for medium, and this is for high. See, so it is going like there is an association, like it's different. And if I draw bar stack 100% stack bar chart for the above example for gender, right? So we are having all the bars same, the two bars same, but the 100%, it will be like it was 25 and 22%, right? So it was somewhat similar. So can you just see the difference between the two bars, two charts?
Yeah.
You getting my
Yes, ma'am.
point? Yeah. So in this, there is so much of difference, like it's similar only. So there is no association between them. But in this chart, we are having an association. We are having difference, right? For the low, majority of them are not having. For high, majority of them are having a smartphone, right? So we can conclude some result from this chart, right? But we cannot conclude anything from this. Like everything is same. So this is 100% stack bar chart. In this, we are not considering the frequency, we are just considering the proportion. That's it. Everybody got my point?
Yes, ma'am. But like, what's the reason? Like, if there is a like a very fluctuation in the data, like we can say कि there is a association.
Mama,
But if there is no,
झुमकी पहन लो।
sorry,
एक बार तो पहनती
hello.
हो कब?
Please,
हैं?
can you just repeat your question?
Like why this is happening? Like, okay, if there is a like very difference between the proportion, so we can say कि they like we can associate some variables, but if there is no like if
See,
the
the
variable are
conclusion
like
that we are
similar.
having, yeah, see, the conclusion is we are having some data. Okay. So above we had some data here. Okay. We had some data and we drawn the chart here. Okay. So this is the stack bar chart and this is the 100% stack bar chart. Okay. So here we are finding out that there is a relationship, like the income is associated with this owning a smartphone. And here we see the gender is not even associated with owning a smartphone. It does not, like, oh, we don't care, like, it does, the owning a smartphone, it's not dependent on the gender, it's dependent on the income, how much income you have. If you have high income, then you will buy a smartphone, of course, right? If you're not having an income, low income, then you won't be buying a smartphone, right? So
Yeah.
in generally, if you see, like, if you imagine it, so it's basically like the income is generally related to owning a smartphone, not the gender, right?
Hmm.
Yeah, that's the thing.
Yeah, ma'am.
That's the association. Is it out clear? This
Okay,
was the
ma'am.
question you asked.
Uh, yeah, ma'am. Like this is like, but we are saying now, ki if we see very like difference in relative frequency, so ki like that variable is not associative.
Yeah.
Like, mm, like what's the reason? Like why this? Like if we have very difference in like relative frequency, why does it affect to that association?
What do you mean by relative frequency?
Okay. Uh, like it's a ratio of like frequency upon total
We
frequency.
are just calculating apart from a whole, right? That's the thing. That's the relative frequency, right? Like in
Yeah.
second week, I told you what is relative frequency. It is a part from a whole.
Yeah.
We are calculating a part. So from that whole part, we are having a small part, right? So that is the relative frequency. So if you look into the table, like from the 38%, we are having 10% as a people who are having a high income and not owning a smartphone. So from that, like we are with relative frequency only, we can calculate some, we can visualize or we can have some information, right? Not from the frequency. We are calculating the relative frequency. From that part, from that whole part, how much part is represented by that category? That's the relative frequency. Got it?
Yes, ma'am.
So till now, anybody having any doubts? No. Sorry. No. Anybody? No one is having any doubts?
No, ma'am.
Okay. So can we proceed further?
Yes.
Okay.
Yes, ma'am.
Okay. So this was about the categorical variable. Okay. Now we will have the now we will calculate the association between the numerical variable. Okay. So the first step is in numerical variable, we are going to construct a scatter plot. So what is a scatter plot? How do you calculate a scatter plot? Okay. So we are having an x-axis and a y-axis. This is the y-axis and this is the x-axis. And in the x-axis, the variable that it displays is the explanatory variable. Okay. And this is the response variable. So what do you mean by explanatory variable and response variable? Okay, if I'm having a data of age and height, fine. We are having ages as 1, 2, 3, 4, and 5. And we are having height as 75, 85, 94, 101, 102. Okay. So in this, what do you mean by explanatory variable? Explanatory variable are the variables in which that explains anything. Like and someone was saying something. Your voice is not. Can you speak louder?
Ma'am, go forward.
Yeah.
Avoid
So
it.
yeah. So explanatory variable are the variable which explains something, right? So if here we can say the age is explaining the height, right? Height is the response variable and age is the explanatory variable, right? So the age is explaining the height. So if we are having ages like 1, 2, 3, 4, if the age is increasing, that means the height is also increasing. So sorry. Okay, so this is the age that is 1, 2, 3, 4, 5, and here we are also having some values. Okay, so for one, it was like 75. Here we are having 75. Then we are having 85. Then we are having 94, 101, and 108. Right. So this is the scatter plots. Scatter plot is that this dot is representing the value. Okay, the two like it displays the pair of values, right? So this is representing 1 comma 75. This is representing 2 comma 85. This is representing 3 comma 94. Similarly 4 comma 101, and this is representing what it is representing.
Number 5, 5,108.
5 comma 105. So this scatter plot is represented by dots, and these dots are displays the pair. Okay, the pair of values it represents. Fine. And for the in x-axis, we have our explanatory variable, and the y-axis, we are having response variable. Is it clear?
Yes.
Fine.
Yes, ma'am.
Okay.
Yeah.
Now we are having the scatter plot. So how we will describe the association with the help of scatter plot? So there are 4 things. Okay. The first thing is the direction. Okay. The second thing is the curvature. The third thing is
Variation.
variation. And the fourth thing is
Outlier.
outliers. So in direction, we are having like patterns, like if it's up, down, or no directions, right? So in directions like this is one graph. So we are having scatter plot like this. So this is in what direction? Anyone?
Upward, ma'am.
This is upward direction, right? Similarly, I'm having a graph like this. So what is the direction?
Downward.
Downward. Okay. So this is the first thing. So from this, we can see if the direction is upward or downwards. Then the second thing is curvature. Curvature means like if it's having any curve or if it's linear. So in the first, like in these two, it's linear only, right? There is no curve. You getting my point?
Yes, ma'am.
This is linear only. And here also it's linear. It's a straight, like similar to a straight line. Now, what do you mean by curve? If this is my graph, okay. And so here we are having a curve, right? An upward curve. Similarly, we will have a graph like this. So here we are having a downward curve, right? There is a curve. It's not a straight line. So in curvature, we would be having curve or we would be having a linear line. That's it. You getting? Direction and curvature is fine by everyone?
Yes, ma'am.
Okay. Now we are having variation. What do you mean by variation? Okay. So like if I'm having a graph, like this. So here we see the dots are tightly clustered here, right? They're not far apart, they're close to each other, right? So this is tightly clustered. So there is no variation here, right? Not that much of variation here. If I'm having a graph like this, see, the points are far apart. That means they are variable. The variations are there between the data points, right? Here we are not having any variations. Here we are having data variations here because they are far apart. Okay. So in variations, we have tightly clustered points and we are having variable, right? It's fine.
Yes.
Yes, ma'am.
Everybody understood about variation?
Yes, ma'am.
Okay. Now comes the last point, that is outliers. So I'm having a data point like this is the graph. I'm having some points as here, here, and here. So if you see here, these 4 points are far away from these points, right? They are not into this group. So that means they are outliers. They are not like these data points are far away from the rest of the data points, right? So they're outliers. Got it?
Ma'am, how it will affect on the association between two numericals, those outliers, ma'am?
How the outliers are?
How will the outliers will affect on the association? That's what I'm asking.
Yeah, they will somewhat they will affect like you're calculating like if you're calculating like covariance or correlation, so it depends upon the outliers. Like that you will know later, like after some point you will get to know. We will like in later weeks we will tell you about that. Fine.
Okay.
So till now everybody understood, right? So how we describe the association with the help of scatter plot, with the help of direction, if it's an upward direction or in downward direction, then if we are having a curve or we are having linear, right? If there is any variation or there are any outliers. So these are the 4 things that we see in a scatter plot. Okay. See, like from the direction, what can we say about the association, right? Like if it's like the values of x are increasing, that means the y is also increasing. If the values of y is we can say that if the values of x is increasing, the value of y is decreasing from the downward, right? There is the curvature is like if it's curve or linear. So from these 4 things, we can you can say from graphically we can describe an association. Everybody got my point?
Yes, ma'am.
Yeah. Okay.
If they are it's they get out in the graphs, then you can say that the values are increasing exponentially. Like
Sorry, what?
nothing.
So this was graphically represented the association between numerical. Now we will numerically represent with the help of measure of association. And that measure of association are,
Covariance and correlation.
yeah, correct. So there are 2 things, that is covariance and correlation. So what do you mean by covariance?
That quantify the strength of the
They
linear
define the
association.
strength, they define the strength of the linear association. Okay. We are only considering the linear association here. We are not considering any curved association. We are only considering the linear association. So covariance, it quantifies the strength of the linear association between the 2 numerical variables. Okay. And what is the formula of covariance? It is summation of xi minus x bar into yi minus y bar
minus y bar
divided by
and
n, right? So here the x is one variable and y is another variable, and x bar is the mean of that first variable and y bar is the mean of that second variable, and n is the number of, we can say,
observation.
the observation of frequency or n. Okay, so let's do an example. Okay, so we are having one column as age, the other column as price. Okay, we are having ages as 1, 2, 3, 4, and 5. We are having price as 6, 5, 3, 2. Okay, so first of all, we have to calculate what that is xi minus x bar. So age is an x variable and price is y variable. Now the third column will be xi minus x bar. X bar. So first of all, we have to calculate the x bar. What is x bar? That is the mean of the x variable. That is the age. What is the mean of age? It will be, what is the formula?
3, 3, 3,
It will
3.
be 3.
The mean is 3. Okay. What is the formula of mean?
Total number
Sum.
of
Sum
sum
of
of
observation
total
divided by the total
observation.
number of observations. Okay. And what is the mean of y variable?
92.6.
Huh? Mean of y variable.
4.
4. Correct. Okay. Now we are going to calculate the deviation. That is xi minus x bar. So it will be 1 minus 3. It will be
Minus 2.
minus 2.
Minus
Then
2.
tell me the values.
Minus 1.
Minus 1,
0,
0,
1, 2.
1.
2.
Okay. Similarly, we are going to calculate for the y. That is 4, 6 minus 4, 2, 1,
0.
0.
Minus 1.
minus 1. Okay. Now we are going to calculate the product. So it will be xi minus x bar, yi minus y bar. So it will be minus 4, minus 1, 0, minus 1, and minus 1. Then we are going to calculate the sum. What will be the sum? Minus 12.
34 by
Okay, so yeah. Till here, anybody having any doubt in the calculation?
No, ma'am.
No, ma'am.
Fine.
Until then, no doubt.
Okay. Now, the formula was summation of xi minus x bar into yi minus y bar, that was minus 10, divided by, that is n. So how many observations are there? 1, 2, 3, 4, 5. That is minus 10 divided by 5, which will be equal to minus 2. So the covariance is minus 2. Okay. And remember that we are dividing it by n, right? So here it is population covariance. If I have to find out the sample covariance, then what will be the formula? Summation of xi minus x bar, yi minus y bar divided by
N minus 1.
n minus 1. So it will be minus 10 divided by
4.
4, right? So it will be equal to minus 2.5. Got it?
Ma'am, how to know the number of n?
N is number of observation. How many observations are there? 1, 2, 3, 4, and 5. Got it? That is n.
If it is not similar, x equal to 6 and y equal to 7, how to find the n?
That is not possible.
Okay, ma'am. Thank you.
So till now it's clear? Yeah. You're having doubt? Anybody having any doubts?
No, ma'am.
Okay,
No, ma'am.
fine. Now, okay. So now here we calculated the covariance. So what will be the unit of the covariance? See, the upper part was summation of xi minus x bar and yi minus y bar, right? So for x, the x was representing the age. And what is the unit of age?
Years.
It's years. Okay. And y is representing the price. So it is in lakhs, right?
Yes.
So the unit will be years into lakhs, right? So like it's not quite representable, or like it is not interpreting correctly, right? We are not having values which are having units as years and lakhs, right? It's not quite representable at all. So we are going to have a measure which are unitless. So here then we calculate the correlation. Getting my point? Why we calculate the correlation? In covariance, we are having units, right? And what is the unit? The unit is years into lakh. Or if we are having any different variables, so we would be having any other, like we are having centimeter and meter. See, the variable, the units are different, right? So if we are having any quantity with variables as centimeter into units as centimeter into meter, so that's not quite representable, or it is not, it's difficult to interpret in, right?
Ma'am, covariance itself does not affect on the strength of association. Ma'am. Like correlation can affect, but covariance itself does not affect.
Your voice is breaking. What?
Covariance itself doesn't affect on the strength of the association, right, ma'am? Is it right or no?
I'm not getting it.
He was asking about the effect of covariance on association. How it represents an association.
The association.
Ma'am, I'm just asking about the covariance itself doesn't affect on the strength of the association, right, ma'am?
Yeah. It
But
just calculates
correlation
the
can affect.
deviation. That's it. It calculates the deviation between the two variables.
Yeah,
Here,
but doesn't affect on the
in the
strength of the
covariance,
association.
we are calculating the deviations here, right? And we are just multiplying it.
Yeah, ma'am.
Yeah. So that's it. So here, like then the covariance is are having units, but we want the some quantity which is unitless, right? It would be having like centimeters, like if both the variables were same, if the units were same, then it would somewhat be interpretable, right? But we are having the units different, so it is not interpretable by us. So for that we calculate the correlation. Everybody got it?
Yes.
Okay. So what is correlation? Correlation is, it is the linear association between the two numerical variables. Okay. And it is represented by R Okay, which the formula of correlation is covariance between x and y divided by the standard deviation of x and standard deviation of y. Clear? So this is the Pearson coefficient correlation. Got it?
Yes, ma'am.
And why it is unitless? Can anybody tell?
Divided by the
Because it is the ratio of same type of variable.
Yeah. See, the covariance, the covariance of x, the units were centimeter and lakhs, right? And standard deviation of x is also having the same units. That is the x is the same as the x variable. That is, it will be centimeter only, and for the y it is lakh only. So the units are getting cancelled. So that's why it is unitless, right? And what is the range of correlation? It is from
-1.
minus
-1 to
1
+1.
to 1. Yeah. So if the correlation is 1, then we say it is positively correlated. And if it is -1, we say that it is negatively correlated. Got it?
Yes, ma'am.
Yeah. Okay. So in the above example only, if we have to calculate the correlation, so this was the, yeah. So if we have to calculate, the covariance was minus, that is 10 only, right? So the correlation will be R is equals to, that is the covariance, x comma y divided by the standard deviation of x and standard deviation of y. So let's say that the standard deviation of x is 1.58 and the standard deviation of y is 1.582. Fine. So the covariance is minus 2.5 divided by, like if we are calculating the sample correlation, okay, and the standard deviation of x is 1.58 into 1.58. This will be equal to -1. Everybody getting it?
yes, ma'am.
Right?
Wrong with the two Williams equation.
What is your doubt, Megha?
Ma'am, how to find Sx equal to 1.58 and Sy equal to 1.58?
Sx, what do you mean by Sx?
मैम S इक्वल टू 1.58 जो लिख रहा है
Standard deviation.
See, Sx is standard deviation. Okay. And what is the formula of standard deviation?
स्टैंडर्ड डेविएशन
Summation
The
of
root of
xi
variance.
minus x bar divided by
का होल
n.
स्क्वायर भी तो होता है
Huh?
अपॉन n
Yeah.
माइनस
So is it's just the calculation only. It's the standard. I just calculated the standard deviation of x. Okay. So if
It's
you
quoting
calculate,
as the standard deviation, right?
sorry, what?
We calculating the standard deviation
Yeah.
for x. We
Yeah.
use population standard deviation, not the sample standard deviation.
Okay. It will be n minus. Fine. Got it? We are
ओके
just
मैम
putting the values in this formula and we are just calculated the standard deviation. Yeah, I've not calculated here. I just calculated on my own and I got the value as 1.58 for the x variable and 1.58 for the y variable. Fine. And I just put it in this formula only. Okay. And I got the value as -1. Got it? Everybody got it?
Yes.
Yes, ma'am.
Fine. We can also have a formula as R is equals to summation of xi minus x bar, yi minus y bar divided by under root of xi minus x bar whole square and summation of yi
minus y.
whole square. So, like from the table only, you can calculate these values. So, if I calculate summation of xi minus x bar above, it was minus 10. And if I calculate summation of xi minus x bar whole square, right? So, this is the table. So, xi minus x bar whole square will be, that is 4, 1, 0, 1, and 4. So, the total will be 10 only. Similarly, if I calculate yi minus y bar whole square, it will be 4, 1, 0, 1, and 2. Oh, sorry, 4. So, it will be 10 only. So, if I put this value here, it will be under root 10 and under root 10. So, this will be same as minus 1. Fine. Everybody got this?
Yes, ma'am.
Yes, ma'am.
Okay. Now comes like the thing is we quantified the association between the two variables by correlation and covariance. So the thing comes like if we can summarize it by the equation of line. Okay. So when we summarize the association with the line, we calculate the we have the equation as mx plus c, right? Y is equals to mx plus c. Y is the response variable, m is the slope, x is the explanatory variable, and c is the intercept. Okay. So the linear association can also be described using the equation of line, which is y is equals to mx plus c. Fine. Okay. So like if you draw a scatter plot, okay. So if you draw a scatter plot like this, we are having one scatter plot as like this. So equation of line is it represents a line like in this way. Okay. So this line represent the association. This is the line which represent the association between two variables. Okay. And like for example, it represent the equation as 30.5x plus 36. So this is the equation of line, which is this is mx plus c. So this line, the equation of this line is 30.5x plus 36. Okay. So here we also calculate the r square, which is 0.647. So what do you mean by r square? Okay. Anybody?
Goodness of fit measures.
Yeah, it measures the goodness of fit test. Okay, so that means like how good the line is, right? So if I'm having a graph like this, see, if having the scatter plot is like this and having a line as this. So the r square here, it is 0.0322, right? See, the r square value is between 0 to 1. Okay. So if it is near to 1, that means it is a good fit. And if it is 0, that means it is not a good fit. Here it is 0.647. That is, it is near to, you can say 1, right? So it is a good fit line. But here it is near to 0. That means it is not a good fit. Got it?
Yes, ma'am.
Everyone?
Yes, ma'am.
Okay. Let's do this. Yeah. So here we calculated r square was, for this graph, it was like 0.647. And if I calculate the correlation, it is 0.80. So if we see, the correlation is 0.804. Okay, if we square this, we get the goodness of it, that is 0.647. Okay, so like the correlation is nearby 1 only. That means it is a good, the R square will also be nearby 1 only. Here in this example, if you are having R square, the R square was 0.22, right? So if I calculate the R, that is correlation, it will be 0.149, right? So it is nearby 0 only. That's why we are having R square also as 0, right? So we can also interpret by the correlation value also. Fine.
On finding R square, we need an equation. So
See,
how can we
this is
find
the
it?
this is the value of R. The value is from -1 to 1, right? And we are having the value of R square as 0 to 1, correct? So if having like this is the R square one. So if squaring the values of 1, we are getting the value as similar to R square only, that is nearby 1. If I'm having a value of nearby 0 and we are squaring it up, it is getting nearby 0 only. But if we are having the correlation value is negative and we are squaring it up, we get the values nearby 1 only. Getting my point?
Yes.
Got it? So
Yeah.
this this way only we with this only we can calculate the values, like we can also calculate the value of that is R square, okay, from the value of correlation also, just by squaring it up. That's it. Fine.
Yes, ma'am.
Anybody having any doubt?
Ma'am, I want to ask a question that in if we have given a chart, then how we can conclude what is the correlation of this chart, scatter chart?
If you're having a chart, then
How can we find the correlation of that chart?
no, you should have the numerical values. Then only you can calculate the correlation.
Ma'am, just like someone asked in chat, what's a question? Ma'am, can you explain this question? My doubt is from this question.
Which question? Which question?
Ma'am, Sanjeev has asked this question.
Yeah. One second.
From where you are getting those Google form questions? It's I think PYQ, na?
Previous one.
PYQ accessible in Google form. How it's possible?
You can download PYQs from this.
Okay, fine. Okay, I tell you. Is this stats one question paper only?
Ma'am, this Google form PYQ, how can we access this?
Ma'am,
Yeah. No, I'm asking this question is from stats one only. Sanjay, is it from stats one? Hello? Hello.
Yes, ma'am. Yeah, it's at one only. It's about 4 years.
Okay, let me fine. See. We have a graph like this. Then I'm having see. It is like the values are really tightly correlated and the values it's linear. Here it is not tightly correlated, but it is going upwards only. So this is nearby 1. The correlation, the value is nearly positive 1, right? That is, it is strongly correlated, right? But here the value is not 1, but nearby 1. It is close to 1. This is nearby plus 1. So that's why this the correlation of this value will be higher than the correlation of this value. Similarly, it is for the downward trend also. If the values are closely related, that it means they are correlated. The value will be plus 1, close to plus 1, right? And if the values are like this, they're apart from each other, but it is in upward direction, then the values are nearby plus 1. That is, it can be 0.6 or something. And this can be 0.9, 0.8, that's it. It's nearby that. Then this means it's positively, strongly correlated. And this is that it is correlated, but less than A. So this way you can find out the correlation through the graph. Got it? Just look at the data points. Got it?
Data points are
Okay, ma'am.
tightly clustered, then they are close to one.
Yeah. See here they are tightly tight, right? So the values are very close to each other. Here the values are not that close, but it's showing a trend that it is showing an upward trend, but the values are not that close to each other. So if you look into that question, so here the values are like in the A part, it is showing the values are tightly clustered. In B, it is also tightly clustered, but in C and D, they are not tightly clustered. They are like uh, somewhat apart from each other. But the direction is like downwards, and for the D, it is direction is upward only. Got it? So that's why the correlation for
Yes, ma'am.
B like it is close to 0, right? Sorry, close to -1. Then C will be close to like it is not -1, but like it can be minus 0. You can say 3 or 4 something, right? So that is B, C, then D, then A. Got it? So this way you can calculate, like you can find out the correlation through the graph. Everybody got my point?
Yes.
Hmm?
Yes, ma'am.
Ma'am,
Yeah.
ma'am, if the correlation coefficient is near to 0, then
There is no correlation.
ma'am, but it is not equal to 0.
Yeah, it's not like it is nearby 0. That means there is no correlation. If you see in this graph, there is no correlation here, right?
Yes, ma'am.
In this graph, there is no correlation because it is not showing any trend. Like if it's not showing that the values are in x of the values of x is increasing, then the values of y is also increasing or decreasing. It is not showing any trend. It is just showing that it's constant. That's it. The values may be increasing, or maybe decreasing, something. Like there is no changes. So that means there is no association, there is no correlation between them. Got it? Yeah.
Yes, ma'am.
So till here, anybody having doubt? Everybody understood this point? This one?
Yes, ma'am.
Yes, ma'am.
Sure?
If it is downward, then it will be weakly, not strongly.
Yeah, similarly, if I'm having a graph like this only, this tightly clustered, but it is in downward direction, that means it is close to -1. And similarly, if I'm having this type of scatter plot, but in downward direction, it is like nearby 1. That is can be 0. You can say 5 or 0.4, like 0.7, something like that. So it is close to -1, right? The correlation. So see, the values are from -1 to 1, right? So first, like in this question, it was B, then C, then D, then A. So the value of B is -1. Then C, it is nearby -1 to 0. Okay, between -1 to 0. And D, it is 0 between 0 to 1. And A value is 1 only. That's why we are having this trend. B, C, D, A. Got it?
Ma'am, I have a doubt. If a scatter plot represents the data points which are tightly clustered but in the downward direction, then can we say that there is a strong negative linear association?
Yeah.
Okay.
Now is it clear?
Yes.
Ma'am, it will be weak when it's near to 0.
Yeah.
Okay.
So till here, anybody having any other doubts? Can we proceed further?
Yes, ma'am. Proceed further.
Okay. Now, like till now, we calculate the association between the categorical variables and we calculated the association between the numerical variables. Now we are going to calculate the association between the categorical, that is one is a categorical variable and the other is a numerical variable. Please mute yourself. Who is this? Right. So, yeah. So now we are going to calculate the association between a categorical and a numerical variable. And for that, we calculate the point biserial correlation coefficient. Okay. And the formula is, it is denoted by RPV, which is y bar naught minus y bar 1 divided by standard deviation of x under root of P naught and P. So here, let's take an example. I'm having one column as student, as student name. Okay. Then we are having the next as school. Okay. We are having like if the students are passing and fail, let's make that. Like the students are pass or fail. Okay. So we are having values as 1. The 1 is represented as the student are passed. Okay. So 1, 2, 3, 1. Then what are the scores? It is 85, 78, 92, 16, 73, 55, 48, 82, 67, and 50. Okay. So now, if we see here, y bar naught represent like this is the categorical variable and this is the numerical variable. Fine. So y bar naught represent one part of categories. Like If the student is passed, then it is denoted by y bar naught. If the student is failed, then it is represented as y bar 1. Fine. Or you can say 1 is representing the pass. Sorry, this is 1 and this is 0. So y bar 1 represent the average of students who are passed, and y bar naught represent the average of students who are failed. So how do you calculate y bar 1? So y bar 1 is the mean. That is how many students are passed. Anyone?
5, madam.
If you have to calculate the mean,
Acha. Okay.
so we calculate it as that is 85 plus 78 plus 92. Like we are calculating the mean of y by 1. That is 85, 78, 92, 73, 82, and 67. Okay. So it will be 73 plus 82 plus 67 divided by how many are there? 1, 2, 3, 4, 5, 6. Okay. So if we calculate this, we will get as 79.5. Similarly, we can calculate for y bar 0. It will be what will be the values?
60 plus 55 plus
60 plus 55 plus
40
48 plus
50.
52 divided by 4, right? So the values will be 53.75.
75.
Okay, so we got the values of y bar naught and y bar 1. Now we can calculate the standard deviation of x. Okay, what standard deviation of x means? We have to calculate the standard deviation of this numerical variable, right? So this is represented by x and this is represented.
Ma'am, how can you do calculating y bar?
We are just calculating the mean of y bar 1.
Y bar not y bar 1 is easy, but y bar not in from which value are you subtracting the value 79.5?
We just take the values of like this, like 0, that is 55, 60,
Oh,
40.
okay.
Yeah, fine. Okay. Now we can calculate now we have to calculate the value of standard deviation of x. So x is representing the numerical variable here, right? X is representing the numerical variable. We can calculate the standard deviation here, right? So the standard deviation will be like after calculation, it will be 15.13. Okay, I'm not going into the detail in the calculation, but it will be 15.13. Fine. Now we have to calculate P naught and P1. What is P naught? P naught represent the proportion of students who are failed. Okay, so how do you calculate the proportion? Proportion will be how many students are there who are failed. That is 4 out of how many students were there? There were total of 10 students. So this will be 0.4. Similarly, I can calculate P1. What is P1?
Proportion
Anyone?
of students passed.
0.6.
Proportion of students who are
Pass.
0.6.
who are passed. So it will be
0.6.
0.6.
0.6. So we have got all the values. We have got P naught, P1, y bar 1, y bar naught, and standard deviation. Let's put these all values in this equation. It will be RPB is equals to y bar naught is 53.7. Sorry, y bar. Y bar naught is 53.75 minus 79. Divided by standard deviation was 15.13. Under root of P naught was 0.4 into 0.6. So if I calculate this value, I would be getting minus 0.833. Okay. So this is the point biserial correlation coefficient. Got it?
Yes,
See,
ma'am.
here we are like if I just interchange the values, right? So if I'm denoting 1 as the student who are failed, okay, and if I'm denoting 0 as students who are passed, okay, so I would be getting a positive value. So my values would be RPV is equals to plus 0.833, right? If I
Yes,
just
ma'am.
interchange the values, that's it. So, but we take only the absolute value, that it is 0.833. Got it?
Yes, ma'am.
Yeah. So this is the point biserial correlation coefficient. So if we have to calculate the association between one categorical and one numerical, we calculate the point biserial coefficient, correlation coefficient.
Ma'am, I have a question.
Yeah.
So, do we always take the absolute value for point biserial correlation coefficient?
Just
If
wait a second. Just a
if it is
second.
a negative, just like here, minus 0.833. So if in the question it is asked specifically the absolute value, then only we'll have to give
No, like
0.833.
see, if it's asking point biserial correlation coefficient, it will be minus 0.833 only. Okay. But if we have to interpret it, we take the absolute by taking the absolute value.
Yeah. So only if it is asked specifically the absolute value of this question, then only we give it 0.8.
Yeah. But basically, we are just like the question is we just calculate the point biserial correlation coefficient. That's it.
Yeah. And
Yeah.
I have another question in general. Suppose here the correlation coefficient is 0.835, and if in the question it's mentioned that enter the answer up to 2 decimal places correctly, up to 2 decimal places. So are we truncating up to 2 decimal places, or are we rounding off and then giving the
rounding off?
So if it is 0.835, we have to mention as 0.84. Rounding, we always do
Yeah.
rounding off.
Yes.
Okay. And
So
another,
if
yeah,
like you're asking like if they have been asking about the correlation, it is like if we take the absolute value, it is nearby 1 only, right? So it is positively correlated.
yeah.
Yeah, that's it. So
yeah, in general, just in during the calculations, if we have to mention the answer up to 2 decimal places, then if we have the answer as 0.835 or something, then we generally do the rounding and truncate it to 2 decimal places, right?
yes.
Okay. And for all this calculation, because these calculations take a little longer time doing it through calculator and all, while it is more faster when we do it in an Excel sheet or a Google sheet. Will we have access to either Excel sheet
No,
or
no,
Google
no.
sheets in
No.
the exam?
No.
No, we'll have to do it through the calculator only.
Yeah.
Okay. All right.
Yeah, but we would be getting giving you values which are easy to calculate. Don't worry about that.
Okay. Yeah. Thank you.
Ma'am, in this question you have taken the numerical value as a x, right, ma'am? Is a numerical variable.
Yeah, the numerical variable will be the x and the categorical variable will be the y.
My doubt was is if you are you considered as a general x or the in scattered graph? Scattered graph will be explanatory variable, right? Are you consider this x as that explanatory variable in scattered graph?
No. It's
Yeah,
just that the numerical
general.
variable is considered as an see the sx is representing the standard deviation of the numerical variable, and y bar naught and y bar 1 is representing the mean of the categorical variable. That's it.
while considering a scattered graph, we have to like, interchange those. In general, lectures did write that only.
Sorry, what?
In recorded lessons, they did try that. Your categorical variable they taken as an explanatory, and the numerical variable they as a response variable like that. They taken in
Yeah, yeah.
scattered graph.
Like if you make a graph, you can take it like that.
Okay.
So, yeah. So this was the last topic. So till now, okay, Dipanshu, what is your doubt?
Ma'am, you said that in the end of session you will solve my doubts, so I am here in the end of session.
Sorry, what?
In the beginning of session, I asked
Yeah.
you for.
Yeah, I will solve it. But before that, just let me complete this. Like, if I clear the doubts of this thing first. Fine?
Okay.
Yeah. I'm coming to that. Just don't worry. I will, like, after that only, I will be closing the session. Don't worry. So,
Ma'am,
Ma'am,
how much you will explain today? More?
no, this was the last.
Okay.
So
ma'am, I have a
anybody
doubt.
having doubts still
Yes,
here?
yes.
Yeah.
Yeah. If the value of R lies between 0.25 and 0.50, what we can say about the association?
Sorry,
Is it
what?
if the value of R lies between 0.25 and 0.50, so what we can say about the association? Like it's weak or strong?
It is like mildly, like you can say.
Moderate. You can say maybe.
Like it's between if it's between 0.5 and 0.75, then we can say it's mildly correlated. If it's between 0 and 0.5, we say means if it's between 0.0 and 0.2, we say there is no correlation. If it's 0.2 to 0.5, we say like, yeah, there is some correlation, not that much, but very
Weak
small
correlation.
correlation.
Weak linear
Weak,
association.
you can say, weak, you can say.
I just want to confirm that it's weak or.
Yeah.
Thank you, ma'am.
Okay.
It comes as in sequence absence, weak, moderate, and strong, right?
Yeah, weak, moderate, and strong. Yeah. So if it's between, see, uh, so if it's like this is so this is 0, this is -1, 0, and this is 1. So this is 0.75, this is 0.5, and 0.2. Similarly, we are having -0.2, -0.5, and we are having -0.75. Right? So this is till here we are having strong correlation. Fine. This is mild, moderate, we can say. Okay. And here we are having weak. And here we are having no correlation. Got it?
Yes, sir.
Fine. Everybody got my point? Similarly, for this case, this we will be having no correlation, weak correlation, moderate, and highly correlate. Got my point?
Yes, ma'am.
Got it. Okay. Now, any other doubts?
Ma'am, if it is 0.75, so it will
It will be
come
highly correlated.
Okay. Yeah.
Any other doubts?
Yes, ma'am, I have a doubt. So in the point biserial correlation coefficient,
Yeah.
do we also calculate it differently for population and sample?
Population and sample for point biserial.
Yes.
No, we don't have, because we are not
So
considering the There is no n part here, right?
No, but so we have to calculate the standard deviation in the formula. We take standard deviation in the denominator. So we have to calculate it for the population or the sample.
Population.
Population
only we are calculating.
Okay, and also in correlation.
Correlation, it's
in correlation also we have
in correlation the numerator is getting cancelled only. So whether it's sample or population, the values will be same.
okay. And
You're
what
getting my
about
point? Like if
yes,
you see the
covariance.
correlation here, so we are having denominator here, we are having denominator here, we are having denominator. All the values will be cancelled. So there is no point of having sample or population. It will be correlation.
Okay, so all the n part will be cancelled.
Yeah, see, what is
Okay.
covariance? That is summation of xi minus x bar divided by, like if you are taking n minus 1, that is sample covariance. And sample standard deviation will be n minus 1 and n minus 1, right? It's under root. So these will be cancelled. So only this will be left. So whether it is n or n minus 1, it doesn't like, yeah.
And what about covariance?
Yeah, we are having covariance as sample covariance and population covariance.
Okay, sample and covariance. Okay.
Yeah. Here we
Okay.
we are having
Okay.
population covariance and sample.
Okay, ma'am, understood. Thank you for clarifying.
Okay. Rudra, what is your doubt?
I already asked, I'm doing.
Okay. Fine. So everybody, like all the doubts are clear?
Ma'am, I have one. So if we are talking about correlation and covariance, the association is always linear, right? Between them, it's not curvature. Because somewhere during the course I have come across that it is defined for linear association. So if these two,
we are only taking the linear association for correlation and covariance. We are not taking the curvature, just the linear association.
okay. So if just to visualize how the graph would look like if the correlation and covariance values are given, then it is always a linear.
Yeah, linear.
Okay.
Yeah.
Okay. Yeah. Thanks.
Any other doubts?
Yes, ma'am, I have a general doubt.
Yeah.
I have not took maths 1. I have not selected maths 1 while admission in foundation level. So while in the upcoming weeks there will be any problem, is maths 1 a prerequisite to stats 1? There's something common in those?
I don't think so.
Okay.
Yeah, I don't think so.
Okay, ma'am. Thank you.
Ma'am.
Yeah.
Yeah. So if they're asking proportion and percentage, are they both the same? Because some questions they've asked a proportion of so and so, while some questions are related to percentage of thing. So proportion is without multiplying the number by 100, is it?
Mm-hmm.
When we
proportion is different and percentage is different. Yeah.
Sorry.
If you multiply the proportion by 100, then you will get percentage, and if you
Percentage,
don't
right? Yeah.
multiply it by 100, you will get proportion.
So proportion is basically just the fraction
Yes,
without
yes.
multiplying it by
Yes.
100.
Yes.
Okay. Yeah.
So any other doubts? Anybody having any other doubts in this week 4 for today?
No, but can you please share the link of the spreadsheet?
Sorry? Sorry, what?
I need the link of the spreadsheet. That's a previous lecture.
You're not clear. Can anyone just tell me what he asked?
He's asking for the spreadsheet of previous sessions. Because spreadsheet with
Slides of the previous sessions, he is asking.
Slides of the previous session for week 3. He's asking for week 3.
They didn't specify that.
Who was this? Ashu, I think, right? Ashu?
Yes.
Yeah. So Ashu, tell me which week you want. Week 3, right? I think it will be uploaded.
It will be uploaded in the supplementary content
Supplementary
of it.
content. Just look
Yes.
in that.
We will get there.
Yeah. So, okay. Now it's fine by everyone. The doubts are clear.
Yes, ma'am.
No one is having any doubts. Okay. So, yeah. Okay. Now, Dipanshu, you were having doubts, right?
Yes, ma'am. I have sent you direct message. You can see there.
Is the week 3 the deadline is over? You have submitted it?
Yes, ma'am. On 16th of October.
Okay. So, what is the formula of variance? Variance is summation of xi minus x bar whole square divided by f. Is asking sample. So it will be in minus 1. Fine. Here we have the mean as x bar sigma minus 6. Okay. So first of all,
We have
x
to
bar
find
is,
the correct mean.
yeah, x bar is summation of xi divided by n, right? So
Yes.
it is given by summation of xi minus 6. So summation of xi will be 19 into 6.
114.
114.
I'm getting the correct mean approximately 19.66. I have doubt in the sample variance, not the mean. I have code this, but not the next step. Then you put the correct value of mean in the sample variance. Yeah, ma'am, in this step I am getting confused. Hello.
Hello.
Yes, ma'am, in this step I'm getting
Yeah.
confused.
I'm just- Will you be taking a session tomorrow, Hindi session?
What, ma'am?
Will you be taking Hindi session tomorrow?
No, ma'am.
No. Okay. On Tuesday, doubt session.
No, ma'am, I don't join these session. I join them only when I have doubts. So for this doubt, I have already joined many sessions, and now I am not going to join any session in future for this particular doubt.
Okay, okay, fine.
Here you have to take the sum of squares of x1 to x5 maybe, because the number of observations are 6. So you have to take the squares of all those 5 observations, and the sixth will be the correct observation, mean minus correct observation. No, no, no. 7 minus 19.66, maybe 11 minus 19.6.
The answer is 64 something you're getting. That's fine.
Hello, Dipanshu, can you tell me what we have to find in which question it is?
Yeah, I can send you first.
No, which question is it?
Graded assignment, week 3 graded assignment, question number 3.
Okay, you send me the question.
Ma'am, if you are facing difficulty in explaining this in English, you can use Hindi.
What?
If you are facing difficulty in explaining this in English, you can use Hindi.
You can? If you use this formula, I have to use this formula for the variance. Like if you use this formula, the summation of xi square, just calculate the like we calculated the summation of xi, just calculate the summation of xi square. So how did you calculated it?
Ma'am, I have done by this, like in this step, the 405, you get 405 here. And on the left hand side, I added the five observations, xi minus x bar whole square to x5 minus x bar whole square, x1. Okay, and then last observation, I took 7 minus 19 square, which is I assume that the observation is the last observation, which is 7. Okay, so I have subtracted 19 from 7 and squared the whole term. So I got 261 of the sum of x1 minus x bar to the x5 minus x bar whole square. And then I applied again applied sample variance and then put the value of this. I got 261 and the correct difference of mean and the correct observation.
Okay, we are just taking the sample variance formula as summation of xi square minus summation of xi whole square divided by minus 1. So this is the formula that we are taking, right? So sample,
I don't know this formula, man.
it's the same as this only, xi minus x bar. What is x bar? That is xi
Mean.
summation of xi divided by n only, right?
Oh, okay.
So, ma'am, if it is same, then we can also solve with this also. We can use this formula also.
Sorry, what?
If these two formulas are same, then why we cannot use this formula, initial formula?
This one.
Yes. What is the difference?
There is no difference. It's just the calculation part only. This is much easier if we are having a table and we can calculate the summation of xi minus x bar. For the calculation part only, this table is much easier. That's why.
Ma'am, from 11 you will subtract the new mean and square, no?
Yeah, that's what I'm thinking.
And from 7 the old mean.
Okay, okay, I got it. The old one was
19.
mm,
Ma'am, I think you're not squaring the terms.
okay.
Hello, ma'am. I have solved this question on the paper and I can show you on the desktop. I have created PDF. If you allow me to share the screen, I can show you I how
You
I
have got the
solved it.
answer?
Yeah, I was getting 67 point something, but the correct answer is 64.1
Yeah,
to
the 60.
64.7.
Yeah, the correct answer is that only.
If you allow me to share,
Just a second. Yeah, okay. Mm, I don't think so. I have.
Dipanshu, can you share your question?
yeah, who asked?
Yeah, now
Can
you can
yeah,
share your screen. Who was asking?
Yeah, ma'am. Are you able to see my screen now?
Yeah, yeah.
Yeah, ma'am. Here I have, you can see their number of observation are 6 and the whole mean is given 19 and the sample standard deviation is 9. So here I have calculated the sum of 5 observations. I have let them x1 to x5. So the sum is 107. And here on the right hand side, I have calculated the new mean, which is equal to 19.66. Okay. And in this step, we know that sample variance is equal to the square of standard deviation. So it is coming 81. And here I applied the formula of sample variance. And here I squared the each observation, which is
Okay,
from
fine, fine.
x1 to
Yeah.
x5. And then I have taken the wrong value and subtracted the wrong mean
Okay.
here.
Mm.
And by using this formula, I have got the value of x1 to x5. But the main concern is here when I am applying the formula for new sample variance, the value that I have got here in these values, the mean here is the
Yeah, that's
wrong
the
mean, which
thing.
is 9.
It's the wrong mean. Yeah, that's the thing.
Yeah.
So here we
So
are not
here,
going to use this formula. That's what I'm telling you. This is not the formula that we are going to use. Just solve by this formula that I told you, right? Summation of xi square minus summation of xi upon n whole square divided by n minus 1. Just solve it by that. You will get
if
the
you
answer.
can show me
Okay.
now.
Are you in disclosure?
Yeah, I have closed the.
Have you posted the question there
Where, ma'am?
in disclosure?
In disclosure? No, ma'am, no.
Discourse. Is it discourse?
Discourse, sorry, discourse.
Okay,
Yeah.
okay. He is qualified student, I think so. He is having Google groups.
Okay. Let's solve it here.
Dipanshu, send the question.
Yeah, sending you.
So Dipanshu, I am getting the answer is 63.93 as the old variance. Is it the correct answer?
Yeah, the correct range is from 64.1 to 64.7.
64.1 to 64.7. Okay, okay.
Yes. Everybody has this question in their graded assignment. Maybe it's question number 3, but with different values. So you already know how do you solve that question in your graded assignment when you submit that. Ma'am, in this formula, there is no difference. So we can also find the answer by using that formula that I showed you.
There is no difference.
Yeah, there is no difference
In what?
in the formula that you are using and that I have showed you on my screen.
मैम मेरे फॉर्मूला सॉल्व कीजिए ना, हो जाएगा बहुत आसानी से.
हाँ, तो यही फॉर्मूला तो है. इससे पहले लाइक वी आर जस्ट कैलकुलेटिंग समीशन ऑफ एक्स आई स्क्वायर. After calculating summation of x I square, we can add and subtract 11 minus the mean. Then we can
मैम
have the value. Because if
मैम
you use this formula, yeah,
मैम स्क्वायर्ड सम डिवाइडेड बाय n माइनस वन. होल में n बाई n माइनस वन नहीं लेना है. स्क्वायर्ड सम डिवाइडेड बाय n माइनस वन माइनस सम ऑफ ऑल ऑब्जर्वेशन का द होल स्क्वायर डिवाइडेड बाय n इंटू n माइनस वन.
Ma'am, the method I showed you is incorrect or correct?
that's incorrect because see the values like if you're using this one, right? The values they're already subtracted by the old mean, but we have to subtract
Yes,
it by the
yes,
new mean.
yes,
So you can't use that formula. So that's why
yes.
we are using this formula.
So can you tell me the difference? What is the difference in these formulas, these two
Yeah, here
formulas?
we are like in this we are going to subtract it with the new mean. That's the thing. That's the difference. So we can subtract it by the new mean, so we can have the value of the sample variance.
Ma'am, I'm not getting this point. Can you please explain this in Hindi?
Mhm. Okay.
Ma'am, is it possible to make a video of the solution and put it in the course material?
No, we don't provide for. We haven't provided
Ma'am,
yet.
I have asked this doubt to like two instructors before you, and they were also not able to solve that question, and they said me to ask in the open session, and now it is seems that you are also not able to solve this.
Yeah, just give me some minutes actually. I have to solve it, right? So this.
If the instructor are taking too much time to solve one question, then बच्चों से कैसे एक्सपेक्ट कर सकते हैं कि वो ये क्वेश्चन सोल्व कर दें.
हाँ मेरा भी गलत हो गया, सही बोलते हैं.
मेरा सही है, बहुत आसान है. तुमको जो फॉर्मूला भेजे है ना उससे करो.
कौन सा फॉर्मूला, ये दूसरा वाला?
हाँ हाँ, जो भेजे हैं वही.
Which formula?
So,
Yeah, that's the same formula जो मैं use कर रही हूँ.
सेंड किया मैंने फोटो।
Summation of all observation divided by n whole square it should be. Not n minus 1. Hello, Deepak. It should be. Hello. Shouldn't it be sum of all observation divided by n whole square? That's the mean, right? Hello.
Yes, ma'am.
Yes, ma'am. What?
The summation of the formula that Deepak has shared is summation of square sum divided by n minus 1, it's okay, minus summation of sum of all observation divided by n whole square, it should be. Not only that. The formula is incorrect.
Yes, yes. And, मैम ये फॉर्मूला सही है मैम, इसने जो भेजा हुआ है?
नहीं नहीं, उसमें सबमिशन ऑफ जो जो मैंने लिखा है ना
हाँ।
फॉर्मूला, ये वाला फॉर्मूला है। ये जो
मैम
फॉर्मूला
इधर
है
19 के नीचे n की वैल्यू नहीं दी ना आपने इधर।
हाँ करेक्ट, वही परिवर्तन।
6 होगा इधर शायद।
नहीं जो हमारा मीन है वो तो हमें दे रखा है ना, 19 है जो एक्स बार है।
अच्छा अच्छा अच्छा। तो मैम अभी ये कैसे सोल्व होगा, अभी बताइए आप।
दीपांशु एक बार करेक्ट रेंज जो है ना आंसर की वो चैट बॉक्स में लिख दो।
19.66।
नहीं, रेंज आंसर की रेंज 64 ऐसे कुछ था ना।
मैम जो अभी तक मेथड बताया था ना लेक्चर में, उसके हिसाब से तो मेरा 67 आ रहा है, बट
Yes, ma'am. Mine also 67.
या किशोर, he was also there in that session, if he remember. I
At
asked.
first, I did using wrong mean. My answer was coming 65. Then sir told to use the correct mean. Then I subtracted the correct value from correct mean. Then
Yes,
it's coming 67 point something.
yes, he was also there, ma'am, when I asked me this doubt from sir. And he replied that in the upcoming sessions he will come up with a better explanation, but I don't know when he will come with that.
कितना आ रहा है? 67.22 आ रहा है क्या?
हाँ, इतना ही आ रहा है।
हाँ, तो मैंने भी चैट जीपीटी में 2 बार डाल के देखे अभी चेक करने के लिए, वही सेम आ रहा है 67.2।
अभी जो अपने को फॉर्मूला बताया है उसके हिसाब से तो यही आना चाहिए।
वही आ
अभी
रहा है, मेरा
इनका
भी वही आ रहा है।
अभी इनका सर्वर ये बता रहा है, तो अपन क्या कर सकते हैं उसमें।
या तो रेंज गलत हो सकती है।
हाँ, इनका सर्वर वो रेंज बता रखा है ना गलत।
हाँ, ये हो सकता है। और मेरे
या
जो अलग मतलब मेरे नंबर्स भी अलग थे, उसके अंदर भी रेंज के अंदर वो भी आंसर गलत हो गया।
या फिर इन्होंने जो मेथड बताया कैलकुलेट करने का वो रॉन्ग है, क्योंकि अभी तक एक ही फॉर्मूला बताया है इन्होंने अभी तक।
देखो अगर हमारा अगर जैसे जो रेंज है उसमें नहीं आ रहा है, तो हम चेंज मतलब उसका इवैल्यूएशन हम नहीं करेंगे। तो हम सॉल्व करके देखेंगे। तो अगर हमारा वो रेंज के अंदर आता है तो ठीक है, अगर नहीं आता है तो उसका हम इवैल्यूएशन हम देख लेंगे क्या करना है। ठीक है,
अरे एवेल्युएट तो हो चुका है जब
इवैल्यूएट
आप।
हो चुका है।
हाँ, एवेल्युएट हो चुका है, मार्क करो।
सबका आंसर सेम आ रहा है 67, मतलब रेंज के बाहर ही आ रहा है
रेंज के बाहर ही आ रहा है नंबर।
सबका।
हाँ, लगभग सबका। आपका कितना आ रहा है?
मैम जो मैंने मेथड आपको दिखाया था आप उसको गलत बता रहे हो, तो फिर सही क्या है, आप सही बताओ ना हमें।
कौन सा वाला मेथड? ये फॉर्मूला मैं बोल रही हूँ, सबमिशन ऑफ। क्योंकि हमारा फॉर्मूला क्या होता है, सबमिशन ऑफ एक्स आई, सबमिशन ऑफ एक्स आई माइनस एक्स बार होल स्क्वायर डिवाइडेड बाय n-1 होता है, राइट? तो अगर उसको
Yes.
ओपन करोगे तो समीशन ऑफ एक्स आई स्क्वायर माइनस डिवाइडेड बाय n-1 माइनस समीशन ऑफ एक्स आई समीशन ऑफ एक्स आई अपॉन में n होल स्क्वायर डिवाइडेड बाय n-1 होगा, तभी तुम्हारा जाके ये बनेगा, जो तुम्हारा होल स्क्वायर जो बनेगा। अगर तुम ये वाला फॉर्मूला जो तुमने लिखा है वो करोगे तो कैसा?
ये मैंने गलत क्या किया है इसमें, ये बताओ आप।
फॉर्मूला गलत, सम ऑफ ऑल ऑब्जर्वेशन।
मैंने बस इधर वैल्यूज लिखी है, बाकी करा तो सही नहीं है। मैंने बस
अच्छा
x1 से x5 ले लिया है।
अच्छा दीपांशु, ओके।
Ma'am, I think the error is coming because in question the student has subtracted previous 5 values from the old mean, and
हाँ
we are not
वही वही
rectifying
मैंने
that.
कहा है, वही तो
यही
मैंने
डाउट तो मैंने
कहा।
पूछा था किशोर, उस दिन मैंने यही डाउट पूछा था सर से।
सर ने क्या बोला?
सर ने बोला कि he will come up with the better explanation. He was not able to explain that at that time. उससे पहले मैं एक और इंस्ट्रक्टर से पूछ चुका, अभी कितनों से पूछूं मैं, अभी आप तीसरे हो।
उनका आंसर क्या आ रहा था?
उन्होंने सोल्व भी नहीं किया ना, उनको समझ नहीं आया क्वेश्चन उस टाइम।
Ma'am, he solved a different question,
या
and he used the method means he subtracted the correct mean from correct value and wrong mean from wrong value, and he added the correct square term and subtracted the wrong square term.
हाँ, जब अपन ने पूछा था कि ये गलत मीन से हो गया ना सब्ट्रैक्ट, तो फिर उनके पास कोई जवाब नहीं था, तो उन्होंने बोला
अच्छा
कि
एक काम करो, तुम कल का ज्वाइन कर सकते हो स्टार्टिंग में, तो मैं डाउट तुम्हारा कल क्लियर कर दूंगी पक्का। तुम कल ज्वाइन कर सकते हो हिंदी सेशन?
कल कितने
स्टार्टिंग
बजे
के
है मैम?
10 मिनट्स में मैं समझा दूँ।
कितने
बताओ।
बजे है मैम कल सेशन?
6 बजे।
शाम
आंसर क्या आ
को?
रहा है?
सॉरी,
इससे पूछ रहा हूँ मैं, आंसर क्या आ रहा है?
आंसर चैट में देख ले भाई।
64.47 है क्या?
हाँ, इतना ही रेंज आ रहा है, कैसे आया भाई तेरा, बताइए जरा।
मेरा इसी फॉर्मूला से आया भाई, फोटो खींच रहा है, देख लो।
किधर?
Ma'am, ma'am,
हाँ जी।
can I ask one general doubt?
या
Ma'am, in categorical data, we use bar chart and pie chart. In numerical data, can we use bar chart?
Yeah.
Ma'am, for numerical discrete grouped data, we can use no bar chart for single value data.
Sorry, what?
Ma'am, in numerical for continuous, we use histogram. And for discrete, there are two things, ungrouped discrete data and grouped discrete data, where we have frequency. So in grouped discrete data, we can use bar chart.
No. For that we have histogram,
No,
right?
it's just you can't use the bar chart. It's just representing the discrete values, right? So if you're using group discrete, so you will use the histogram.
But ma'am, it's a discrete single value data. And in lecture, ma'am has explained by drawing the bars. And she said that I'm not connecting the bars because it's not continuous value.
Yeah, like if the bars are connected, that means it's a continuous. If it's a discrete, then we use the bar. So, but you told me it's a group.
Yes, ma'am, grouped. We have frequency and it's discrete data, discrete grouped data.
Okay. Like you're, yeah, you can have bar.
We
Yeah.
can, and ma'am, for discrete ungrouped data, suppose we have marks of 5 students, then we can do nothing. Neither we can draw a chart and nor we can create a frequency table
Why?
because we don't have any frequency, ma'am. Then how we can create a frequency table?
No,
It's
you can't create the frequency, but you can create a chart, right? For the first student, the marks is this, the second.
but ma'am,
Yeah,
it's
you can create bar chart.
but it's we don't have any frequency, ma'am. Then how can we create a bar chart?
No, we have frequency. We will have frequency in discrete numerical data, right? Ungrouped discrete numerical data.
Ungrouped data, it's
Yes,
all
we
the
will have
values are
frequency. If we have repetitions in the data, we will have frequencies.
okay.
So if we have dice numbers like 1 to 6, and we will have, if one use the dice 100 times, we will have 100 numbers from 1 to 6, and we have frequencies for 1, 2, 3. Understood?
But wait, one example. Suppose we have marks of 10 students and they are all distinct marks. No two marks are repeating. Then how you will draw the bar chart?
So this is an exception.
Okay. Because that's the example when you go to the mean part, then first ma'am has used
No, we
discrete.
have frequency. Here also we have frequency, but we have frequency of 1.
Yeah, but we need frequency more than one to create bar chart, right?
No. The problem is that we can create bar chart, we can create frequency table, but it is not meaningful. We can create, but it is not meaningful.
Because all the bars will be of same size.
Yes, we cannot compare anything because the data is all equal.
Okay. That's why means we are not drawing because there is no meaning for that.
No meaning for that.
Okay.
We can
And
draw.
but a discrete grouped data where there is frequency, we can draw bar chart, right?
So discrete, what you are saying?
Discrete grouped where we have frequency.
Where we have frequency discrete group data. We can draw
Like,
bar chart also, histogram also.
no, histogram we draw only for continuous data, right? Here we have discrete values.
Okay. No, for histogram we use for ungrouped data. Either it is continuous or discrete.
No, histogram we use for continuous grouped data, right?
Yes.
Then
No,
for
if it is grouped, then we can use histogram.
no. I am sure continuous grouped we use histogram. I'm just
Yes,
asking that.
he's saying right. If you can take the example of class interval of marks obtained of 50 students in a particular course, and you in this example, you can only make histogram of that data, not any other thing.
Yeah, that's continuous data. That's fine.
Yes, it's
But
continuous data.
suppose we have a response of 15 individuals. The example if we'll go to mean for grouped data,
Yeah,
discrete
I'm
single value
there.
data.
Yeah, I'm there. I can see that page. I have noted on
Yeah.
my notebook.
For that, how you will draw the continuous one? We have to draw the bar chart only, right?
Can you repeat? You said what? 15 individuals? What?
It's an example when ma'am
A
was
response
teaching the.
from 15 individuals.
Yeah.
So it is a
It's a
discrete.
discrete single value data.
Like
Means,
a rating from 1 to 5.
Okay.
yeah.
Okay. So what we would have?
Then we can draw only bar chart for that, right? We cannot draw a histogram because we don't have class
Yes.
intervals there.
We can draw bar chart for this data, not histogram, because that's not continuous data.
Okay.
Okay.
Now I understand.
Because
Thank you.
it has a discrete single value data. Because
Then we can say, right, that for numerical, we can draw both bar chart and histogram.
For
Because
numerical.
in discrete, we can draw bar chart, and continuous, we can draw histogram.
Yes.
Okay. Thank you.
So can we not draw bar chart in continuous data?
No, we cannot.
No, we cannot.
Okay, so because the data is continuous and we have too many of decimal values because of that?
No, because we always have a class interval. And when we have class interval, the bars will automatically get, consecutive.
Okay.
So it will automatically become histogram. It will not remain a bar chart anymore.
Okay, understood. So yeah, bar chart, it is bar chart only, but it is truncated, so it looks like histogram.
Yeah, for bar chart, we should have space between the two bars.
Space between them. Okay, I understood. Thank you.
Okay.
Hello, ma'am, are you there?
Yeah, I'm there.
So when will you solve my doubt?
Ma'am, it's been 45 minutes and I think you should close this session and just so we don't waste our time. Also, you can have some time to solve this question.
Yeah. So that's why I'm telling you, like, can you just come tomorrow at 6? Like, I will solve your doubt. Can you just give me some time?
Sure, ma'am.
Will you join tomorrow?
Yes.
Sure.
Yes.
Ma'am, I have sent the solution.
Sorry, what?
I have sent the solution. Please look
Yeah,
into
I
it.
am looking into the solution, but the answer is fine, but I'm just confused.
Why?
Me too.
Yeah,
Can
I
you just
also saw
explain?
the
Why?
solution, but
So,
the
Deepak, can you
steps are.
explain?
See, I देखो मैंने पहले ही तुम लोगों को ये बताया था, फॉर्मूला बताया था ना, स्क्वायर्ड सम डिवाइडेड बाय 5 माइनस सम ऑफ ऑल ऑब्जर्वेशन डिवाइडेड बाय n into n minus 1.
हाँ, तो इधर यही फॉर्मूला यूज किया है ना इसमें।
हाँ, यही फॉर्मूला यूज किए हैं। देखो, तो पहले स्टैंडर्ड डेविएशन में जाओ ना, उसको स्क्वायर करो। सेम टू सेम तुम लोग के सामने ही तो किए हैं, कहाँ पे कंफ्यूजन है? कैलकुलेशन भी पूरा कैलकुलेटर से ही किए हैं। रख दो, रख दो। हाँ मैम,
Yes.
कहाँ पे गलत है ये पूछ रहा हूँ।
नहीं,
भाई
गलत
उसमें
आंसर
स्टैंडर्ड
चलो।
डेविएशन कैसे कैलकुलेट किया उसके अंदर?
स्टैंडर्ड डेविएशन का फॉर्मूला दिए तो है।
वो स्टैंडर्ड डेविएशन स्क्वायर होता है ना उसका, सैंपल वेरिएंस का, तो
स्क्वायर
उसने
सम
रूट
है,
को
देखो
इधर ले गया वो।
पहले स्क्वायर सम करना है, ठीक है ना, जो कि हम लोग को नहीं पता है कि स्क्वायर सम है क्या उसका। लेकिन सम ऑफ ऑल ऑब्जर्वेशन तो पता है ना, न्यू मीन तो आ गया ना हम लोग के पास, पहले वाला मीन तो था ना हम लोग के पास।
हम्म।
ये देखो,
मीन से ही
मेन
ना
डाउट
पता चलता
क्या
है,
है
सम ऑफ
इसमें,
ऑल
जैसे
ऑब्जर्वेशन हम लोग के पास होना चाहिए। पूछो पूछो।
जो ये तुमने रूट के अंदर स्क्वायर सम बाय 5 लिखा है,
हाँ
इसमें जैसे एक्स एक्स वन माइनस एक्स बार होता है, तो उसमें जो एक्स बार है वो तो इसमें पुराने वाला ही है ना।
तो
ठीक
पहले
है।
आप अब निकालना क्या चाहते हैं? देखो मेरा बात सुनो, सम ऑफ ऑल ऑब्जर्वेशन हमको पता चल गया है कि नए वाले ऑब्जर्वेशन का सम ऑफ ऑल सम क्या है, न्यू मीन हम लोग को पता है ना।
हाँ हाँ।
तो 118 देखो साइड में लिखे तो हुए हैं वहाँ 118, मतलब सम ऑफ ऑल ऑब्जर्वेशन जिस टर्म का हम लोग को चाहिए, नए वाले का चाहिए, तो सम ऑफ ऑल ऑब्जर्वेशन हम लोग को बस पता चल गया कि 118 है। बस स्क्वायर्ड सम हम लोग को नहीं पता है। अगर जाएगा तो उससे
हाँ तो स्क्वायर्ड
हम
सम की
लोग
तो
को जो,
बात कर रहा हूँ ना मैं, स्क्वायर्ड सम की बात कर रहा हूँ। जैसे जो तुमने ये स्क्वायर्ड
हाँ
सम लिखा है ना इसके अंदर, रूट के अंदर, तो
हाँ
उसमें जो
हाँ,
फॉर्मूला में होता है कि एक्स एक्स वन माइनस एक्स बार होता है, जो एक्स बार होता है वो मीन होता है ना। तो जो ये तुमने इधर
अरे
9 दिया है जो कि रोंग है,
क्या
जो
क्या
कि रोंग,
9?
इधर तुमने, हाँ 81 दिया है ना, ये रोंग सैंपल वेरिएंस है पुराने वाला, क्योंकि
सैंपल
अपने को नया
वेरिएंस
फाइंड
थोड़ी
करना
है,
है।
ये तो स्टैंडर्ड डेविएशन है ना।
अरे 81 तो सैंपल वेरिएंस है ना।
हाँ 81 सैंपल वेरिएंस, क्योंकि उसका स्क्वायर की तब आया 81 है ना।
हाँ ठीक है, तो इधर स्क्वायर सम में तो वो ओल्ड मीन लिया है ना
पहले
तुमने,
मेरा
न्यू
बात
मीन
सुनो,
तो नहीं लिया।
पहले मेरा बात सुनो सुनो, जो तुमको फॉर्मूला भेजे
देखो,
हैं।
ओके, जस्ट अ सेकेंड, एक मिनट। देखो, सबसे पहले मीन और स्टैंडर्ड डिविएशन है 19 और 9, ठीक है। टोटल ऑब्जर्वेशन हमारा 6 है। तो न्यू मीन क्या है
हम्म
हमारा? x/6, दैट इज
हाँ
19।
मैम,
तो हमने
इधर तक
समीशन ऑफ
क्लियर
एक्स
है।
आई की, समीशन ऑफ एक्स आई 114 है, ठीक है। अब इनके फॉर्मूले के अकॉर्डिंग अंडर रूट स्क्वायर रूट सम डिवाइडेड बाय 5 माइनस स्क्वायर रूट सम का मतलब दैट इज समीशन ऑफ एक्स आई स्क्वायर की वैल्यू है, ठीक है।
हाँ
समीशन ऑफ एक्स आई स्क्वायर डिवाइडेड बाय 5 माइनस समीशन ऑफ एक्स का होल स्क्वायर डिवाइडेड बाय 30, दैट इज n इंटू n माइनस 1 इन्होंने किया है, जैसे 5 इंटू 6 दैट इज 30, ठीक है। ये लाइन
हम्म।
समझ आई? 9 इज इक्वल्स टू ये, ठीक है। अब जो
मैम,
स्क्वायर रूट हमने
why he
हटाया
is
है,
using 114?
114 हमारा समीशन ऑफ एक्स आई है ना।
But when we corrected it, it became 118, right?
नहीं नहीं
तो
नहीं, ये हम पुराना वाला ले रहे हैं अभी।
Okay.
हम अभी पुराना वाला समीशन स्क्वायर एक्स आई स्क्वायर निकाल, ठीक है। तो हम पुराना वाला
Okay.
सारा ले रहे हैं। तो हमने सॉल्व करके हमारा समीशन ऑफ एक्स आई स्क्वायर निकला 2571, ठीक है। यहाँ तक क्लियर है सॉल्व करने के बाद?
हम्म।
ठीक है। अब हमारा, अब नया वाला निकालना है, दैट इज हम माइनस करेंगे 7 का स्क्वायर को और प्लस करेंगे 11 स्क्वायर, ठीक है। तब हमारा 2643 आएगा। तो हमारा समीशन ऑफ एक्स आई स्क्वायर जो नया वाला है वो 2643 हो गया, डिवाइडेड बाय n-1 दैट इज 5, माइनस में अब हम 118 लेंगे, ठीक है। 118 का स्क्वायर डिवाइडेड बाय 30, ठीक है। फिर जब हम सॉल्व करेंगे तब हमारा 64.47 आया, ठीक है।
वही
तो
तो
ये मैम
मैम
सही है अभी ये
चाहिए
मेथड।
था। सुनो सुनो सुनो, एक ही चीज चाहिए हम लोग को, सम ऑफ ऑल ऑब्जर्वेशन हम लोग के पास है कि नया वाला सम ऑफ ऑल ऑब्जर्वेशन क्या है, 118 आ गया है ना, नया वाला मीन आ गया ना हम लोग के पास, सम ऑफ ऑल ऑब्जर्वेशन सॉरी 118 आ गया है। एक चाहिए क्या, स्क्वायर्ड सम ही तो चाहिए, पहले वाला स्क्वायर्ड सम
हाँ तो
निकालो
इधर
हम लोग।
इधर इधर
हाँ
है ना, तुमने वो वैल्यू नहीं पुट करी ना, बस तुमने इसको वेरिएबल मान लिया। अब वेरिएबल की वैल्यू तो कुछ भी हो सकती है जैसे,
अरे
तो तुमने, अरे मैं समझ गया बस अभी यार, सही है।
हाँ बस मैम समझाइए यार।
क्या डाउट है बताओ, मैं सॉल्व
अभी
करके इसको सॉल्व करूँ क्या वापस?
नहीं, सोल्व क्या करना है, इन्होंने कर तो रखा है अभी।
हाँ, बट डाउट क्या है? फॉर्मूले में
क्या?
डाउट है? क्या डाउट है? प्रोसेस में डाउट है? क्या प्रोसीजर में डाउट है? क्या क्या डाउट क्या है?
जो मैं मेथड मैंने यूज किया था उससे फिर गलत क्यों आ रहे हैं, वो भी सेम ही
देखो
है, मुझे तो
तुम्हारा
ऐसा
जो,
ही लग रहा है।
नहीं, देखो तुम्हारा मेथड क्या है, अगर तुम अपना मेथड देखोगे ना, उसमें तुमने क्या किया है, देखो सबसे पहले तुमने मीन निकाला है, x1 x5 तक का निकाला है, फिर तुमने न्यू मीन निकाला 19, वो सब सही है, ठीक है।
ठीक है।
सैंपल वेरिएंस तुमने 81 निकाला, फिर तुमने
ठीक है।
ओल्ड सैंपल वेरिएंस निकाला समीशन ऑफ x1 माइनस x बार, ठीक है, ऐसे x5 माइनस x बार होल स्क्वायर प्लस में
ठीक
144,
है।
ठीक
ठीक
है।
है।
तो तुम्हारा x1 माइनस x बार स्क्वायर प्लस करके x5 माइनस x बार होल स्क्वायर तुम्हारा 261। तो ये जो
ठीक है।
तुम्हारा x1 माइनस x बार है, तो यहाँ पे जो तुम x बार यूज कर रहे हो वो तुम क्या यूज कर रहे हो?
ये तो पुराना मीन है ना।
पुराना वाला में, ठीक है।
हाँ।
ठीक है। अब तुम जब न्यू सैंपल वेरिएंस निकाल रहे हो समीशन ऑफ x1 माइनस x बार होल स्क्वायर प्लस में x5 माइनस x बार प्लस में 11
हाँ।
माइनस
हाँ।
19.66, ठीक है,
ठीक है।
ये कर रहे हो। तो उसमें जो तुम्हारा क्या बोलते हैं, जो x1 माइनस x बार टू x5 माइनस x बार होल स्क्वायर, उसकी वैल्यू तुम क्या पुट कर रहे हो?
पुरानी मीन है, यही तो डाउट था मैम मेरा उस दिन
हाँ,
सर
तो
से।
वो पुराना है ना, तो वो हम यूज नहीं कर सकते ना। हम
तो
यहाँ
सर
पे
ने
तुम
मुझे ये बोला था कि अपन ये यूज कर सकते हैं, उस दिन सर ने मुझे ये बोला था।
यूज कर सकते हैं बोला।
हाँ।
उस लाइव सेशन में हम भी थे मैम। उस समय सर अलग फॉर्मूला से कर रहे
वो
थे,
फिर
क्या
कुछ
पता कौन
अलग
बता रहा
सिचुएशन होगा, वो
था, वो अलग
सिचुएशन
कर
अलग
रहे थे।
होगा। हाँ, उन्होंने फॉर्मूला अलग यूज किया होगा।
अच्छा। तो जो
भाई
फॉर्मूला
हम
अभी
स्क्वायर्स,
जो मेथड मैंने यूज किया इसमें हम करेक्शन क्या कर सकते हैं? अभी कौन से स्टेप में करेक्शन हो सकती है इसमें जो मैंने यूज किया है?
वो करेक्ट नहीं होगा भाई, उसमें 5 वैल्यू हम लोग को मालूम ही नहीं है।
अच्छा, तो ये मतलब लग ही नहीं सकता ये वाला मेथड इसमें?
नहीं, वो
भाई
लगेगा
तो
ही
वो
नहीं,
कर ही
क्योंकि
नहीं
वो
सकता
स्टूडेंट पहले ही एरर कर चुका है अब उसमें।
हाँ।
भाई
तो
हम
ये
ये स्क्वायर सम तक समझ गए हैं, 2643, उसके बाद ये जो सैंपल वेरिएंस निकाले हो उसमें मतलब डिवाइड बाई 5 भी समझ रहे हैं, लेकिन माइनस क्यों किए हो? -13924/30।
देखो देखो देखो, वो 118 हम लोग का नया मीन है, सॉरी सम ऑफ नया ऑब्जर्वेशन है, सम ऑफ ऑल ऑब्जर्वेशन। देखो ऊपर देखो, एक बार के ऊपर
हाँ हाँ
118
हाँ हाँ हाँ, वो देख रहे हैं।
118 का जो होल स्क्वायर करोगे तो भाई यही आएगा ना।
अरे वो ये पूछ रहा है कि माइनस क्यों किया है?
माइनस
अरे
क्यों कर रहे हैं मतलब?
क्योंकि फॉर्मूला ही यही है ना, स्क्वायर्ड सम डिवाइडेड बाई 5, फिर सम ऑफ ऑल ऑब्जर्वेशन। तो हम लोग का नया सम ऑफ ऑल ऑब्जर्वेशन क्या है? 118 है ना।
वो मतलब दोनों जगह तुम वेरिएंस का फॉर्मूले बदल दिए हो।
अरे
मतलब वहाँ
कहाँ से
पुराना वाला
फॉर्मूला सीख रहे हो?
मतलब वही भाई, वहाँ पुराना वाला यूज किए हो, यहाँ नया वाला यूज किए हो। वहाँ घटाए थे तो ओल्ड वाला स्क्वायर सम कैलकुलेट कर लिए, फिर उसको यूज करके न्यू
ओल्ड
वाला
वाला स्क्वायर सम निकालना था कि कैलकुलेट करना था, पहले ये बताओ।
कैलकुलेट, वही तो बोल रहे हैं।
अरे तो निकालोगे तो नए वाले फॉर्मूला पे ही लगाओगे ना। अरे मैम समझिए यार।
अरे तो मेरा बात तो सुनो भाई,
हाँ हाँ बोलो ना।
जो तुम ओल्ड वाला स्क्वायर सम निकाले हो
एक बात
उसके बाद
बताओ,
तुम
एक बात बताओ, ये फॉर्मूला है